Hello, and thank you for coming out. This is Practical Network Defense at Scale, or defending the Eilange Volmilk cell. So, who am I? My name is Travis Carelock. I am currently an engineer at SoundCloud. Before that, I was a technical and content director at Black Hat, and before that, I worked at the Louisiana Department of Justice. So, this talk is going to be primarily about defense. I've been around the conference series for quite some time now, and a lot of times in these security conferences, you leave with a sense of doom and gloom. A lot of times, you hear about how everything's broken and how bad of a shape we are in, and it's true. But I wanted to make a different type of presentation. I wanted to make a presentation that hopefully you guys can take back with you and use some of the techniques that we discuss here. So I love defense. I love understanding the network. I love building walls and traps and that sort of thing. What I don't love is this. And many of us in this room are paid to avoid something like this. So we're going to be talking about building defense. I'm going to be focusing on building a network scalable SIEM. A SIEM is a security event and incident management system. But like I said, a lot of the techniques that go into building this SIEM, I believe you could probably use in your own environments. So when I decided to write this presentation, writing about defense is a little tough because every organization has its own set of things it needs to defend. And so there is no one easy button. There is no easy answer on how you're supposed to do it. It really depends on your organization. So again, I decided to talk about the process of building one of these scalable SIEMs and all the different types of questions you might have to ask yourself if you're going to build something like this. So that's how I'm going to structure this presentation, as a series of questions that you would want to answer. The very first question, and it seems simple, but it's crucial. The very first question you're going to ask is, what am I trying to accomplish? Now, like I said, it seems like a simple question, and if you talk to people outside of your security team or outside of your organization, they may say something like this. We want to just stop the hackers, right? We want to stop them from getting in. We want to protect all the stuff and just stop them. But you and I both know that this really is not a realistic goal. It doesn't do anyone any good to fear some amorphous person in the sky that maybe has more caffeine, more time, is better financed than you. It really doesn't help. What does help your defense is a realistic and detailed understanding of your infrastructure or your environment. And in fact, this is the very first step in answering the question what you're trying to accomplish. Because without this understanding, you're not going to know your goals. So this part is required. You have to understand and do a thorough risk analysis of your environment. So in order to continue with this presentation, I need to have an example network for you guys. I need to have an example type of environment that we can apply the next group of questions to. I've chosen this sort of network. So this is a highly active network. It's got thousands and thousands of nodes in it. It performs billions of user requests a day, and it may serve hundreds of millions of logged in users each day. This network is generally very flat, which means that all the nodes can talk to each other. But it's, like I said, it's really, really active. I can't say this is the SoundCloud network, but it might be something similar like that. So let's look at what any one of these nodes in this network might be. So any one of these nodes, they could be installed on some sort of physical hardware. They could be a container or a virtual machine of some sort. They might be the networking equipment driving the infrastructure. They might be your cloud instances. Most environments nowadays have some sort of cloud component to them. Or they could just be, in general, users coming into your network to perform some sort of action, VPNing into your network or something like that. So these nodes pop up and perform some sort of action and then go away. Now, these nodes could be doing any number of things. They could be servicing some microservice or some sort of web scale application and all of its dependencies. The node could be a database or part of a database cluster. It might be part of a service-oriented cluster or like a scheduling cluster that schedules apps. It could be, again, your DNS, your DHCP, your internal network services. These nodes could be load balancers. So they might be accepting traffic for a whole host of scaled applications behind it. These nodes might be your business people coming in, querying your databases so they can get insights into their business intelligence. They might be, like I said, your administrators and your systems engineers coming in, making vast changes to your network. It might even be a security device that you've built that comes in and scans to try and figure out what's going on. But the most important thing is we want to make sure it's not this. We want to make sure that none of these nodes are some sort of zombie or malicious entity that's pivoting around your network or doing some sort of thing. So I wanted to step back a second and talk about nodes in general in the modern infrastructure. In the old days, and unfortunately I'm old enough to be in the old days, this is how we treated our servers. Generally, our servers were pets. They were so hard to configure, they were so hard to keep running that your uptime counter was everything. You strived to do whatever you could to keep these servers up and running all the time. In fact, this caused a huge problem because people wouldn't apply security patches or updates to these servers because they were scared what would happen. Well, now we've moved beyond that a little bit. And some people have suggested that we see servers this way now. Yeah. We see servers as cattle. So this means that something happens to the node, something happens to the server, hard drive goes bad, someone RMs the important directories. No big deal. We just pull up a new node and hook it up to the load balancer or whatever we need and continue along our way. But I really don't think cattle does justice to what the modern system administrator or system engineer wants in a node. They want this. Now, what is this? This is from my title. This is a Eilänge Wollmilchsau. So I recently moved to Germany, and I came across this term. This term is used to describe this mythical beast, and directly translated, it is an egg-laying, wool-producing, milk-giving pig. And it's in German culture, it's a slang for a catch-all. It gives you anything you need at any time. And I believe this is what your modern systems engineers want out of a node. They want that node to be anything at any time, whatever they may need. So for example, a node might be part of a database cluster, so it's serving database traffic. But then 30 minutes later, that database might be moved into some sort of cloud instance, and that node is then destroyed, and in its place, 2 more nodes come up and might have the same, one of those nodes might have the same IP, and now it's serving application traffic. So it's completely changed. Or maybe during peak times, we have a certain application that has normally 50 nodes associated with it, but it's a peak time, so we want to scale that up to 150 nodes. And all the dependencies that microservice might need, we of course need to scale that up as well. So now when we look back at our infrastructure, we see this giant flat network. And it's, like I said, it's serving billions of user requests every day. And each user request is this fan-out sort of process that contacts an innumerable amount of databases. Not innumerable, but a lot of databases. And any node can be anything at any time, querying any type of data that they may need. So now, how do you know what the malicious entity is? How do you know where the problem is? Well, it can be trouble. But don't panic, and we just need to start simple. So going back to what we're trying to accomplish, now we have this very dynamic network. It's churning nodes constantly. what are some of the things, what are some of the goals we might want to accomplish in such a network? Well, for very starting, you might want to investigate network traffic. I'm going to go through these individually in a second. You also might want to have network traffic rules and alerts. And of course, you're going to want to have some sort of forensic analysis store. You're going to want to store this data somewhere, so if you do have a compromise, you can go back and understand what really happened. So what do I mean by investigate network traffic? Maybe I have a node or a logical grouping of nodes that make up a scaled application. And I want to know how that scaled application or group of nodes interact with the rest of my network. I might want to know all the IPs for that application or those group of nodes and all the IPs that it talks to within my network. What ports does it connect to? And of course, we want to know how much data is transferred. So that would be maybe a simple goal about investigating network traffic. We might also want traffic rules. So we have a node, and we have a database cluster, and we want to allow that node to query that. So that's fine. Or maybe that node is a logical grouping of nodes in the form of some sort of application, and we want to allow that to contact that data source. Maybe we have two applications, and we want to allow both of those. But we want to make sure that nothing else in the rest of the infrastructure can query that. That would be an example of a traffic rule. Or if something does query it, send an alert. In addition, we might have that database cluster, and we want to make sure it never, ever speaks to the internet. This is a good rule. So those are examples of our network traffic rules. Maybe I also want to do the forensics and analysis. So I need a long-term storage for this data. That's pretty self-evident. And some way to collect that data to perform evaluations. So we have some goals. We want to investigate network traffic, and we want to write traffic rules. What are our sources of truth that will answer the questions that I'm trying to ask? Where can I get the data that will tell me what I'm trying to do? Well, one of the primary sources of truth I think is really great on a network is traffic flows. So things like S-flow and net flow. What this is these are from a router's or switch's point of view, what goes across its backplane. What's the source IP, what's the destination IP, and how much traffic was sent from that router's point of view. But you wouldn't want to stop there. You also would want to include firewall logs and other type of networking equipment logs. IDS logs are very important. Bro, network monitoring, is actually a great tool. I suggest you guys check it out if no one's used it. It will actually do packet analysis as traffic flows across the interface. You're definitely going to want to collect logs from DHCP and DNS and other networking services. You want to do host-based logs. So this would be, of course, all your auth logs. But then think outside of that. So maybe your rootkit hunters, your audit-D, some of your application logs could come off the host. So that's another source of truth. Of course, database logs. Those are always important. And then, again, if you're using a cloud-based service, many of them emit their own type of logs. For example, like CloudTrail and Amazon, or S3 access logs, so you can tell what's happening to your S3 buckets. And you're going to see this icon a lot in this presentation. This is an icon I'm using for custom code. So maybe there's nothing on your infrastructure that's emitting the type of data you need to answer the question you want to ask. Maybe you need to code something that will tell you this, that will emit a certain type of log to give you that source of truth. And almost certainly you will. So a couple of things to consider whenever you're talking about these sources of truth is how consistent is this data that you're receiving? Is it erratic? Which means, can you be certain that the data is actually measuring what you think it's measuring? These are very important when you're considering these log types. How independent is the log? And by how independent, I mean, when you talk about a compromised system, say a box might be, or a node might be compromised, the logs you're going to get from that node are not very independent. but maybe the logs from the networking infrastructure around it would be. How easy is it to corrupt these logs, either in transit or in storage? It's also super important. And all of this will lead you to some sort of confidence score. A confidence score is how confident am I in this log that it's telling me what I think it's telling me. If we go back to that compromised node, now I'm going to read all the logs. I'm going to gather all the logs off that system and read them. But my confidence score probably won't be very high, but I'm still going to read them. And then retention policy, that's also very important. Retention policy really is dependent on your infrastructure and what's in that log. There are some in Germany, there are some laws that say I can only keep certain types of logs for a certain amount of time because they contain user data or PPI, personally identifiable information. And so those laws can only stay for a little bit. But you need to make sure it's long enough so if a compromise does happen, you have the data there. So retention policy is really important and is kind of dependent on the log. So now we have this source of truth. One of the problems I see that happens a lot is people will collect logs. They'll say, oh, yeah, I'm logging everything. But they just dump it into a giant vat or a giant folder, maybe HDFS or something like that. So the logs don't become relative to each other. They're only relative to the log itself. So you're going to want to process your logs before you store them or before you put them into your data store. The very first thing you're going to want to do is normalize your logs. And what do I mean by normalize? Well, each one of these logs have a timestamp. So that's great. Timestamps are very important. But I know you can't see this, but if you look closely, each one of these timestamps are actually in a different time zone. And not only that, but each timestamp is in a different format. So as you ingest these logs, you're going to want to modify that so that it's consistent amongst all your logs. So now you can ask questions like, what happened 2 o'clock yesterday from 2 to 3? What exactly happened across all my logs, not just within one web log or one flow log? In addition, you're going to want to normalize things like the data transfer. All three of these logs have a certain amount of data transfer. But in one of them, it's in bits. I think this one's bytes. And this one can be bits, bytes, or megabytes. So as you bring these logs in, you're going to want to just standardize that to some sort of format. It doesn't matter which one. You just need to pick one. So now you'll be able to understand exactly how much data is transferred when you do just a generalized search over all your logs. You're also going to want to tag your logs. This is really important as well. In this log, all three of these log lines have a source IP in them. Up at the top, this one just has source equals. That's not super useful. And these two don't even have anything next to them. So once you tag them as the source IP for this log, and you can do the same thing for, say, destination IPs, now you can ask across all your logs for destination IP X, what happened? And now you can ask questions like, for destination IP, what happened at 2 o'clock, from 2 o'clock to 3 o'clock yesterday? And you'll be able to find out, be able to easily correlate between all your logs what is going on with this certain node or IP. Also, you're going to want to type your logs. Typing refers to the variable type. So as you chop up your logs and you're tagging and you're normalizing, you're also going to want to type them. So for example, ports. Ports are integers. And once you type it as an integer, now you're able to do calculations that you couldn't do if you just left it as a string. Because most things just leave things as strings. But now that your system knows it's an integer, you can do ranges. You can do, say, show me all the ports from 80 to 90, for example. The same thing with IP. Type it as an IP. So now you can start asking questions such as, for this range of IPs from 10.228 /16 or /15, an odd CIDR, you can now ask questions about an entire range of IPs. This is how you can say, for example, did any traffic go to something that's not in my internal IP range because you've typed them as IPs and not just left them as strings. So now that you're tagging, typing, and normalizing your logs, you can ask questions already. Before we get too far into the system, you can already ask questions like, for this destination IP, how much data was transferred? What percentage change is that from an hour ago? What percentage change of that is from yesterday? So now you can start doing Q-sum scores and things like that. You can start really understanding what's going on. So now we're starting to realize that we want certain logs, and we're starting to pull out certain data types from these logs. Well, what are you going to use to churn all this? What tools are in your toolbox? This, again, is dependent on your sources of truth. For this example, I've decided to use strings and logs and that sort of thing. So probably a lot of you have seen this project. So one of our first tools that we're going to use is the ELK stack. It stands for Log Stash, Elasticsearch, Kibana. And so this is a really popular project. I'm sure a lot of you have heard about it. Log Stash is the thing that you can use to manipulate your logs as you're ingesting them. Once it ingests the logs and modifies it, it shoots out JSON into Elasticsearch. Elasticsearch, you've probably heard of it, is a distributed data store, and it indexes on the fly to make all your logs immediately searchable. And then Kibana is used to then query to create dashboards and to query out from Elasticsearch. And you can create pretty dashboards like this that you can show your boss. Bosses always like really pretty dashboards. But I will have to say, for this project, for this seam, Elasticsearch is the real hero here. Because you can write, and you probably will write once you hit a certain scale. You can write your own ingester. You can write your own Logstash clone. And for sure, you're going to write your own queries. So Kibana is great for visualization. But to ask the really hard questions, you'll probably write your own queries. You're not going to be writing your own Elasticsearch cluster. And to give you an example, currently, I am ingesting, with only 8 nodes, I can ingest up to 1 million log lines in 12 seconds. That's how powerful Elasticsearch is. And if I need to do more, I can easily just scale up. So it's really useful. OK, so now we've got our pipeline, our main pipeline. Obviously, there's a whole bunch of other tools, not a whole bunch, but other tools around here, SFO collectors, rsyslog, those types of things that you're going to use to gather all your sources of truth. But the primary point is you're going to gather your sources of truth to enter the pipeline. Now remember, you're normalizing all this sort of stuff. Now, again, I want to talk about this little icon, the custom code here. As you develop these systems, and especially as you develop in relationship to your infrastructure, you're going to want to write your own stuff. As security professionals, some of us code a lot, some of us don't. For these type of queries, really, it's not going to take a whole lot of major coding. So just pick a language that you're kind of useful, that you're kind of good with, or that you kind of like, and look at the libraries. Don't reinvent the wheel. Just look at the libraries that they offer. A lot of people have been doing similar stuff to this for quite some time. So it's really easy to find some quality stuff out there. But for this type of project, you will get your hands dirty. You will have to write code. So just a side note there. OK, so now great. We're starting to ingest all these logs at a certain amount of time. We have these sources of truth coming in. This sounds pretty good. And we're starting to know things. But right now, all we have is a vat of knowledge. So you have to start targeting. You have to start understanding, what do I want to protect? And really, the only way you can figure this out is to do a risk analysis of your organization. What are the jewels? What are the things that your organization cannot lose? Some places this might be a database cluster. Some places this might be an API endpoint that has access to particular sites of data. It could be financial data on a certain server. Whatever. Just pick your most important target first, and then work your way out from there. So for this example, we're just going to pick a database cluster. Maybe it has some special user information or whatever, but it's a really important database cluster. So at this point, we need to understand, what is normality? what is supposed to connect to this database cluster? Because certainly it wouldn't exist unless you're using it. So what is supposed to use it? What connects to what? Where, and more importantly, where is this database cluster? What nodes is it even distributed on? Where is it deployed? And what is supposed to happen with it? Well, who knows this sort of information? These sort of things know that. So in a scale environment, generally you never hand roll the servers. You have this whole field roughly named DevOps. I'm not sure if many of you heard of it, probably so. And you have these frameworks that basically see configuration as code. And so these are the actual engines. Chef is super popular, Ansible, that sort of thing. These are the engines that will actually go out and take your configurations and deploy that onto a node. So it has that mapping of application to node for you. So that's where you can start to understand where is this cluster even deployed, what are its IPs. In addition, so when you deploy an application, it needs to know how to figure out where that database cluster is. And this is usually done through DNS and service discovery and console, which is a type of in-memory management system. But it has this sort of information. So for example, if a microservice has a dependency, that's where it's going to query DNS or service discovery. And service discovery might come back with 6 IPs for all the nodes that are associated with it. So it'll just pick one of those nodes to go service itself. In addition, you might have deployed to the cloud or to other sorts of cloud services. All these services have their own APIs that you can query to get this sort of information as well. You can query these APIs to get the IP addresses, possibly the tags that you've put on these nodes so that you know what's going on. But that's another source of truth that understands how your environment's set up. And finally, there's always your source code and your repositories. These are invaluable. And again, there's that custom code thing. So you may have to develop your own scraper that will actually go into your company's repositories and look for configuration files. And with these configuration files, you'll be able to understand what that application, once it's deployed, needs to speak to. So one of the things here, I have to say real quick, if you're lucky and your developers only develop in 1 or 2 coding styles or coding languages, then this scraping is relatively easy. In some environments, and especially in startup environments, that's not the case. It's considered a polyglot environment, which means they basically let the developers code in whatever they want to code in and leave it to everyone else to kind of pick up the pieces. In that case, one thing I would suggest is instituting something like a manifest file, where in the root directory of all the source code, it's a machine-readable file that you can go in, and it will say what dependencies it's going to need. That sort of manifest file is very useful, not just to you, but to other members of the organization. So think about that. Eventually, you're going to start to see something like this, a nice dependency graph. So you're going to start to understand what relies on what needs to call what, and how it's going to do it. As you're starting to figure out this discovery, also be thinking about how you're going to automate this in the future. Because sure, the first few times you might go manually look into how these services are discovered or how your configuration systems deploy these nodes. But eventually you're going to want to automate this process, and I'll get to that. So now you're starting to have this view of the world. You're starting to understand where these nodes are deployed and what they need to connect to. And when they are deployed, what systems are they dependent on? So now you're able to have a log line like this come in from your infrastructure, from your networking equipment that said, this IP did connect to this IP on this port. This did happen. And now you have a full dependency tree. You understand what should happen. So you have what did happen, and what should be happening. Anything outside of that is your anomaly, is your investigation. That's where you start to look into it. So now we're able to start figuring out the traffic in between the nodes. We're starting to understand what type of traffic is taking place. But remember what I said about automation, because this view of the world becomes stale very quickly, maybe even a matter of minutes. Your view of the world changes because some administrator or some auto-scaling application changed everything. So again, that's why you're going to want to automate this process, this discovery of your particular world, because it's going to have to happen a lot. Okay, so now we're starting to detect anomalies. It's at this point when you're building one of these systems that you're going to have to focus on false positives. False positives are a bane to your system. They're the things that can kind of bring it all down and make it unusable. A false positive is whenever your system thinks it's an anomaly, but that's actually not, that's actually a good traffic. So there's a couple of things you can start to do about that. First, you can think about better query design. So instead of just asking a simple question, build your query strings with ands and ors, that sort of thing. Or take into account whitelists so that certain things, certain edge cases are taken into account. But generalize, think about how the query that you're asking. In addition, you can query additional services that can tell you if that was an anomaly or not. For example, I have that database cluster, and someone SSHs in, which is a way to modify or log into a node. So someone SSHs in. Well, that's going to be an anomaly. I don't want someone to SSH into my database cluster. But if I can query that IP, figure out that IP that came in, and look up that in a user table, and that user table is one of my system engineers, suddenly that false positive goes away because he's allowed to do that, or that group is allowed to do that. So that's another way to deal with it. Policy and guidelines. For the humans in your organization, think about policy and guidelines, how they construct their apps, how they develop their calls within your network. For example, in that database cluster again, maybe you have master and slave nodes so that read access only goes to the slave nodes, but read writes can go to a wholly separate cluster. So putting in policy and guidelines like that can help you to normalize your traffic, and by normalizing your traffic, it will cut down on your false positives. And always think about blocking. Firewalls, IP tables, that sort of thing. Because if they can't do it, then it won't be a false positive. Blocking can be contentious in a highly scaled environment, so you really need to be careful with that one, but it is really useful if you get it right. So now we're clearing up those false positives. So we still have these anomalies coming in. But not all anomalies are created equal. For example, take an nmap scan. Excuse me. Take an nmap scan onto your external nodes in your DMZ or something like that. An nmap scan coming from the outside. You probably really don't care about that. There's not much you can do about it. It happens all the time. So that's one type of anomaly. Now imagine, though, the anomaly of 4 gigs from your database cluster leaving to the internet. That's a wholly different type of anomaly. So because not all anomalies are equal, the alert actions that result from the anomalies should not be equal as well. So you have to have categories of alert actions. Some alert actions, you might just want to log. Just create another log if that happened. Some alert actions, you might want to mail. Some may send an IRC or an IM or a Slack. Slack's all the rage now. May send a Slack message. Some may go out to PagerDuty. Or page you or send some sort of SMS. And then there's some anomalies that we really want just the alert to put on a pair of pants, buy a bus ticket, ride to your house, and wake you up. I haven't really figured out how to code this yet, but it's a good anomaly. So now that we're starting to bring these back into our system, we're starting to have these alerts. You're going to want to think about making your alerts to feed them back into your system. And think of your alerts as data. Because once you start to think of your alerts as data, you can start doing escalation chains and even kill chains. So what do I mean by that? So an alert escalation chain, maybe a certain number of anomalies only require mail. But if I get 5 of those anomalies that only require mail within 5 minutes, I might want a page about that because something's up, something's weird is happening. That would be an alert escalation chain. And then a kill chain. Kill chain has been pretty popular lately. A kill chain is defined as the actions that a hacker or someone exploiting your system would need to take in order to get to their target and then possibly to exfiltrate that target. So what are the steps a hacker might need to come into your network and then perform his exploitation? So again, this is dependent on your infrastructure. You have to know your infrastructure to know what a good kill chain would look like. But maybe that you see that nmap scan. That's just a log. Maybe you see a user logging in at a weird time. Maybe that's just a mail. Maybe you see that user moving data from your database. Again, that's a mail. But those 3 actions together could form the beginnings of your kill chain. And as your kill chain gets tripped, then go ahead and send me a page. So think about your alerts as data and then act accordingly. Also, something that might affect your alert level action is querying services. Now this is different than querying services to see if this is an anomaly. This is querying services to affect your alert level. So, example, again, you may have a user who VPNs into your data center and they're coming from an odd country. So normally that might send a page because you're not expecting them to come from that country. But if you can query some service that says, oh, that user is at a conference, or that user is registered to be on vacation, or something like that, then maybe you don't want to be woken up in the middle of the night when he VPNs in from the conference. Maybe you just want to get a mail about that the next day. So querying external services can affect your alert levels that result from your anomalies. And now, hopefully, you're building this system not just for yourself to use, but you want to build this system for operators and for people on your team to use as well. Well, alerter fatigue is a real thing. So we've been talking about alerts and all the alerts we can generate, that sort of thing. But what happens if one of your operators gets the same message just 10 times in an hour, and then 2 hours later he gets the same message, and it's not actionable? Maybe he gets that nmap scan. Maybe he gets a mail about the nmap scan. What is he going to do about that? He's not going to shut down the internet. He's not going to go hunt down some IP in some foreign country that's scanning you. So it's not actionable for him or your operator. So why do they even need to know about it? Think about what alerts make it and surface to your operators, because you're going to want to keep them as fresh as possible and interested as possible in the alerts that surface from your system. Because if they start ignoring your alerts, why even have them? In addition, for your operators, think about the user interface that you're creating for the system. For example, say I want my operator to investigate traffic between 2 scaled-up nodes, or 2 scaled-up applications. Sorry. So this application has 150 nodes, and maybe this application has 200 nodes. Well, I'm not going to expect them to type in all the IPs, discover and type in all the IPs for that node. So think about custom dashboard generation for them so that they can easily just create a dashboard with a click of a button, and it will show them all the traffic between those logical grouping of nodes. But outside of that, think about other things you can do for your operators, such as alert management and search, so they can go in and snooze alerts or modify them as they need. Think about the history. Now, this is super important. So what do I mean by history? Take your operator. There's a mail came in that an anomaly happened at 3 in the morning. No, this anomaly wasn't classified high enough to page them, but they need to check up on it the next day. So they come in at 8 in the morning the next day to check on this alert. Well, the view of the world has changed how many times in the last 5 hours? So if they go investigate that anomaly now, who knows what the network looks like? So when the anomaly happens, you need to have a snapshot of your world view so that they can go back and investigate what that was. So providing them a history is really important. Also think about including query tools into your user interface, your UI. This would be like, for example, the tools you use to automate the process of discovery in your network, or possibly other sorts of investigated just scripts and sort of things like that that you use. The simpler you can make this for your operators, the better, and the faster they'll be. And also think about including help. To be honest, this is more for you than it is for them, because they're going to basically ask you the same questions over and over again. And it's much easier if you can just point them to the help. Now, again, we're security people, so we're not front-end developers or anything like that. But you can make something really usable with a small amount of work. For example, I created something like this using Sinatra. It's super simple, lightweight, and does what it needs to do. It doesn't need a lot of flash. So now we're starting to look pretty good, right? We're collecting all these logs. We're chopping them up. We understand our view of the world. We have anomalies. We cut down on the false positives. We have a good user interface for all of our operators to go in. So it looks pretty good. But how well is it working? How do you know if you should have gotten an alert? If you didn't get one, how do you know if it should have happened or not? Is your system working? Think about creating an automated test spot suite. Think about creating a safe automated test spot suite, because we're talking about production here. So you're going to want to make test spots or test scripts that make erroneous connections now and then, and see if your system detects it. You can even make it so that your system expects an erroneous connection from these test spots and sends you an alert if it doesn't see this traffic created here. So that's a good way to test your system. Also think about testing, using scripts to test all the different components of your alerts. Because, for example, Chef uses roles. And say you have a certain amount of roles defined in your alerts. Well, if those roles go away and no one tells you, then they're just stuck there. So, but if you have a script that will go in and test each component, does this still exist? Does this still exist? Does this still exist? Then you know you still have quality components in your alerts, and you don't have some sort of odd cruff or privilege creep or something like that whenever you have old alert styles. So always test what you have beyond build test. Create tests. Also, we're creating a security device here. So you're going to have to think about the system security. By definition, there is specialized sensitive data on this system that we're building. Think about how you're going to protect that. What kind of perimeter are you going to put around it? How are you going to do user auth? How are you going to make sure everything's encrypted that you need to? Because if an attacker can figure out that this is your system that's doing anomaly detection, and they can come in and modify everything, it's game over. So think about how you're going to protect this system itself. Also think about how robust this system might be. If it loses one of its database nodes, can it still do its anomaly detection? If it loses connection to outside data sources, does it have a cached copy of its view of the world? So it can still at least do some sort of anomaly detection until you get those external services back online. So think about how robust the system is and how it can act in the absence of other things. Also, one thing also to consider is think about if this system can rebuild itself if in the absence of the internet. Say you lose the internet in some way, or some DOS attack or something like that. In this system, can the system still function? Can it rebuild itself? Can it see its view of the world without that? So now we have all this data. We're collecting. We're checking for anomalies. It's looking pretty good. But what else? What else can you do with all this data? Like, you have probably one of the biggest data stores and sources of truth in your entire organization. What else can you do with all this? Well, machine learning is probably one logical step. As I've talked about, everything we're doing now is very targeted. We did a risk analysis. We know what we want to protect. We're targeting that and protecting it. But what about everything else? This is where machine learning can help detect anomalies that you're not looking for. Machine learning is its own entire world. Luckily, I have some people on my team that can help me out with this. But it is usable, and I would suggest looking into it. Also, this system could be used by people outside of your security organization. Maybe your system engineers or your application engineers need to understand when they create an application and scales out, and suddenly it brings down 3 databases. What happened? You know, what went awry? Or maybe your load balancers aren't acting like they're supposed to. Or maybe your notifications to the internet for your various services aren't working correctly. Are these signals going out? This is like a free TCP dump for your entire infrastructure. So think about how other teams outside of your security teams can use all this data. And finally, I was in law enforcement for a little bit, and I can tell you the very first thing when law enforcement comes in and they ask, where are the logs? So now you have them. And think about also auditors and compliance. Because now you have the ability to prove something did or did not happen. I know for a fact that database wasn't touched by this group of servers. You can prove that. So we're getting to the end here. And I just wanted to go over some of those questions real quick that I talked about. The first one was, what goals am I trying to accomplish? And like I said, that can only be answered if you understand your infrastructure and your network. What are my sources of truth that will help me answer those goals, that will help me figure out those goals? What tools, considering I know these sources of truth, what tools work best in modifying or analyzing these sources of truth? What is an anomaly? So what is erroneous connections in your infrastructure? What is supposed to happen and what is not supposed to happen? And then, am I correlating my alerts? Do I have a feedback system so that my alerts are now data and I can glean some information from that? And then what about user experience? The more people you can get to use the system that you're building, the better and more active it will be. Is my system robust and secure? It's a security appliance. It should be. And then finally, what else can I do with all this data? I've built all this system. I'm collecting all this. How else can the rest of my organization take advantage of that? So, in conclusion, I just want to say a couple of words. I know defense is hard. Defense is actually really difficult. But you're the hero. You are the one that gets to come in and save the organization. You're the game master. When the hackers come in, they're playing on your turf. So you get to set the rules. So once you understand how everything works in your system, the only thing that can fail you is hardware. And we can always get more hardware. So keep fighting. Thank you.
それでは質疑応答に移らさせていただきます。ご質問ございます方、挙手をお願いいたします。あちら奥の、右の列の真ん中のあたりの方お願いいたします。もう一度手を挙げていただけますか。マイクをお持ちしますのでお待ちください。
ご発表ありがとうございます。ログと格闘する上で2点ほど知見があればいただきたいと思っております。1点目が ログの中で重要なセキュリティに関わるものや非常にシンプルなある種デバッグのためのようなものなどたくさんあると思います。それらをすべて集めるとするとビッグデータなどですらさばききれない量になるかと思っていて、優先順位をつけながら集めてくるということが必要になるかと思っています。そういう時にどのようなログから集めてくるべきかというところで知見があればいただければと思っております。
I'm sorry. I thought she was going to repeat it.
了解しました。繰り返しでございます。2点、翻訳の方も大丈夫ですよね。2点、知見があればいただければと思います。
Hold on, one second.
大丈夫ですか。
Okay, please repeat.
はい、承知しました。2点、質問させてください。1点目が、ログの中にはセキュリティに関わるものですとか、デバッグに関わるような非常に膨大でかつ重要とは言い切れないものなんかがあると思います。それらをすべて集めると処理がしきれないので、優先順位をつけながら集めて CM で分析していくということが必要になるかと思うんですが、その優先順位のつけ方で知見があればいただければと思います。
Yes. When you're starting to ingest your logs, it is true that you probably don't want everything. Some logs are very noisy, and this is the kind of decision you're going to make on the ingestion point. That said, this system, like I said, is handling with 8 nodes. I am processing over 1 million log lines every 12 seconds. So you're able to process a lot of data. And then on the ingestion point, when you tag and type and normalize your data, you're actually able to pick and choose what you want to put into Elasticsearch. So that's a way that you can lower the amount of logging that you're doing. But yes, to your point, some logs are very noisy, especially DNS logs of a certain type. They can be very difficult because they want to give you lots of extra data when all you really want is who's the referrer, who asked for that DNS query. I hate to say it, but it's on a case-by-case basis for each log about how you should do it and what you should chop out. But like I said, at this scale, I am doing quite a bit of logs, and so I almost think more is better as long as you have the storage space. Is really my answer to that.
ありがとうございます。非常に難しい問題かなと思いながらご質問させていただきました。で、もう1点で、オペレーターに見せるべきものとしてご紹介いただいたエラスティックサーチを真ん中に置くログを可視化する基盤もあるかと思いますし、あとお話でありましたアラームを管理するというものもあるかと思います。でそれらはオープンソースなんかも各種あるかと思いまして、エラスティックサーチやスプランクのようなログを見るもの、古くからアラームを管理するザビックスや、ナギオスといったもの、あるいはお客様からの要望や内部のチーム内での課題管理をするレッドマインのようなものなど、さまざまあるかと思っていて、それらを連結させていくという作り方もあるでしょうし、自分で作ってしまうという作り方なんかもあるかと思います。で組み合わせていく形になるとそれぞれ思想が異なるので、なかなか難しい部分があるかなと感じる時がありまして、そこについて組み合わせ方のコツですとか、いっそ割り切って一から作ってしまう方が楽だよというような知見がありましたらいただければと思います。
So the question you're asking is, do I have any tips with regards to visualizing the data or creating your own alerts and using outside tools to complement those alerts? Is that the question?
そういう意味だと、そうですね、連携させるときにオープンソースのものを使っていくべきか、自分で開発すべきかというところです。
Okay, I get it. Always, never try and recreate the wheel. That's just going to lead to a lot of time. When I use the idea of custom code, what I really mean is just small glue code, small little parts, just to fill in the gaps that you need. There's really a lot of work being done in the incident response and data analysis field. And so when you go try and do it yourself too much, you're probably not going to do it as well as some other collective. So always be on the lookout for what's been done before. Like I said, all of this is built with open source tools. I work for a startup, so we don't have a whole lot of money to go buy security equipment. So, but there's still such great stuff out there. There's really a lot of really good things that have been created. The Bro, for example, network analysis is an amazing tool set. But always look around first before you start building, because there's a chance that somebody has a nice library or some sort of tool that does what you need. I hope that answers your question.
ありがとうございます。
はい、他にご質問ある方いらっしゃいますでしょうか。最前列の真ん中の列の方お願いいたします。
ありがとうございます。非常に、ちょっと私も、機械学習だったりこのログ分析周りは、非常にちょっと今気になっている分野だったりします。日本とアメリカでの、そのログ、分析環境だったりその可視化ツールについて、多少事情は、違ってたりとかするのかもしれないんですが、特に、もし、サウンドクラウドの中で、マシンラーニングを使うにあたって、実際に使っているツールだったりとか、なんかこのツールと例えばまた別のツールを、組み合わせて、使うと非常に、有効な、効果が得られるというか、そういったものがあれば何か、ご教示いただければと思います。
So yeah, the machine learning part is the part actually I'm discovering a bit. We have machine learners on my team, and right now they use their own custom code, most of it's in Scala, to detect and to create patterns for spam detection and user analysis and that sort of thing. So actually I can't really recommend any certain particular SBT libraries or things like that because that's more of their field, to be honest with you. I focus on the targeted attack and protecting what exactly you need to protect. And I'll be honest, what I've seen of machine learning, and one of my colleagues had a talk about it today, it's still in its infancy. It can be fooled pretty easily. Even our spam detection can be fooled pretty easily. And so I wouldn't want to trust the crown jewels of my network to machine learning just yet. I don't think it's at that stage in development. So that's why I would always suggest learning your environment and writing rules around what you need to protect. And then with all the rest of the data to maybe to make sure there's no pivoting, some hacker pivoting from node to node within your network, some unimportant node that you don't know about. Maybe that's what you might use machine learning for. But I just don't trust it enough at this stage to just basically flick it on, let the classifiers figure out what normal traffic is, and let them tell me what an anomaly is out of that classifier. Because from my experience, it takes a lot of nuanced work and a lot of testing, and you need to run tests to make sure that your classifier is even classifying what you think it is. So again, I just look at that as the future of a system like this, is you can add on a machine learning component, but I just wouldn't trust it at this moment completely. Does that answer some of your question?
ありがとうございます。
はい、ありがとうございました。もうお一方だけお受けしたいと思いますが、いかがでしょうか。後方の真ん中の列の一番後ろの方、お願いいたします。
ご発表ありがとうございます。サウンドクラウドというその世界中でいろいろなさまざまななんていうんですか、人気があるサービスの中でのご知見に基づいた発表、非常にためになりました。今回ですね、ちょっと教えていただきたいなと思っていますのは、発表のテーマはその外部からの攻撃をどのように防ぐかという話だったと思うんですけど、内部犯行に対してどのように追跡だけではなくて、早期に検知をしてでそれを防いだりとかっていうことをやっていけばいいのかっていうですね。特にクラウドにおいては例えばログの中にも個人情報とかお客様の情報が入るようなこともありますから、それが機密情報がどこに今あるかっていうのもトレースするのが難しい中で、いかに内部情報内部の犯行を防ぐかっていうのをですね、もしご知見があれば教えていただけますでしょうか。
No. Yeah, I didn't want to give the idea that this was mainly against external entities because, let's face it, I'm a security person. I don't trust really anyone, and even internals. So that's why I use, for example, the SSH. I actually want to know when people SSH in. And so that's why I might go query a group to make sure that that person is part of a privileged few that's allowed to do that. Same with your database queries that your business intelligence people might come in. Another thing you might think about is because you're logging all this information and you have your byte transfers as integers, I actually use this technique, you can start to understand what the average user or that particular user, if you can trace it back to a user, how much data they generally transfer. So if suddenly this user that has transferred 5 megs a day in SQL queries suddenly transfers 2 gigs one day, that's a problem. So I actually apply rules to everybody, not just the external ones. And then as far as putting private information in the cloud, that is its own can of worms. Well, that's probably a bad way. That's its own problem. Recently, the EU did away with safe harbor. I'm not sure if anyone was aware of what that is. That means that companies like web-scale companies like Facebook and Google can no longer keep private information, user information, outside of the country of origin. So they can't bring back, there's no safe harbor they can bring back an EU member's private information back into the US. So what we're starting to have to do now is create bastions of network resources that are contained within whatever laws that allow. So, for example, the German law makes us have to contain user information or begin to think about putting user information in certain locations to protect that sort of thing. One thing I would like to mention about cloud services is I don't own stock in Amazon or anything, but remember I mentioned S-Flow is a really great way of figuring out what's going between your nodes. Amazon just 2 months ago released S-Flow between instances. So now you can actually log how your instances talk back and forth to each other, and you can apply all the principles I was talking about to cloud-based nodes. So that's one really useful way to figure out what your nodes are doing in the cloud. But personal information, it's rough, and it is completely dependent on the country and its rules and how it applies to it. That's why I also talked about the retention policy. All of that is very dependent. We have a full legal team that I go and I show them the log, I show them what's in the log, and I ask them, how long can I keep this? And so sometimes you need some outside advice about that sort of thing. I hope that answered your question.
はい、ありがとうございます。非常にためになりました。ありがとうございます。
はい、それでは質疑応答これ、で終了させていただきたいと思います。ではこのセッション終了となります。ありがとうございました。Thank you, Travis.